Good morning. I am Kiran, student of BSc Chemistry Honours, final year, Physical Chemistry Experiment. Aim conductometric titration between strong acid and strong base. Requirements peptide titration flask, funnel, beaker, burette, strong acid, HCl, strong base, NaOH, conductometric. Theory: the titration, in which the concentration of unknown solution is determined by measuring change in conductance by titrating it with standard solution, is called conductometric titration. Principle of conductometric titration: it is a method of volumetric analysis based on the change in conductance of the solution at their endpoint. When one solution from burette is added to another solution taken in titrating flask, the replacement of ion occurs, which results in change in conductance in the resultant solution. If the change in conductance at the equivalence point is rapid, then it can be utilized for the detection of endpoint. NaOH plus HCl gives rise to NaCl plus H2O. Procedure of conductometric titration: the titration is added from the burette and the conductivities are measured during the course of titration. There are two possibilities. Reaction is quantitative. The measured conductivity is the linear function of the concentration of the ion present. Two lines will be obtained in the case with interact each other at equivalence point. Reaction is not quantitative. The measured conductivity gives the curve means the end point, and thus the equivalence point is determined by extrapolating this portion of the curve. In order to get straight line graph, it is essential that the total volume of the solution it remain constant during the titration. So to make the total volume of the solution constant during the titration, an important precaution in the cell the titration is that the solution in the burette should be about 10 times stronger than the solution taken in the titrating flask. Titrating of strong acid with strong base. Procedure: solution of HCl is to be treated against NaOH solution. The acid solution is taken in the beaker and NaOH solution is taken in the burette. The conductance of acid solution is noted initially as well as after successive addition of a small amount of NaOH solution. After the end point, the further addition of NaOH introduces fast moving OH negative ion, and hence the conductance of the solution again begin to increase. If the conductance value are plotted against the volume of the alkali added, the endpoints obtained by the interaction of the lines. Result: molality of the solution HCl is 0.01 mole per diameter cube. Precaution: there should be no air bubble between two electrodes. The titrant must be at least 10 times more than the concentration that the analyze. The conductance cell must always be dipped either in solution or in the distilled water. Thank you.